two of them. So let's move down here. Just can't really see it. Oh, wait, you can. Perfect. We'll move down anyways. This is little. Alright, well, you can kind of see it right there, the little circle I was talking about. Alright, so now if we follow this legend, the first pin is going to correspond to the output. Then the inverting input, non-inverting input, negative power supply. Positive power supply, output, inverting input. Alright, sorry about that. I have Jarvis running in the background, and Jarvis opening a bunch of things and doing a bunch of stuff. It's hard because I have music playing there and I have to pause it and all that stuff. Anyways, so like I was saying, it corresponds, each one corresponds to its own separate thing. So with that, these specific op amps actually have the capability of being two op amps in one, based off of this legend right here. Wish I had a cameraman. You can see A, that could be used for one op amp, and B can be used for a second op amp, all within this one op amp. But to make things simple, I'm actually just going to use two separate op amps. So we are going to do one of the labs today. I already wrote down the values of the components and elements here. So the first one we're going to do is this one, the top one. So we need to get 15,000 ohms or 15 kilo ohms resistance, 0.01 microfarad capacitor, and then we need to have powered the op amp, and then we need to measure across VI and V1. Now with VI, we have to assume, based on the notes, which is the V input, that it's going to be right here. So assume that it is 5 cosine 2 pi 1000 t. Alright, so what this is basically going to correspond to is we don't have a value for phase angle. So this is going to be 2000 pi times t plus 0 degrees. And because it's a cosine, we can just convert it over. So we're going to go convert over to phasor form, which is going to be 5 phasor and 0 degrees. So that's going to be our VI, 5 phasor 0. Alright, so we want to build that. So let's start by getting 15,000 ohms of resistance across the coming out of port 2. It tells us 1, 2, 3, 4, and 8. These are the ports that are going to correspond to the op amp ports. So on here, since this right here indicates top, it's going to go 1, 2, 3, 4, then jump to this side and go 5, 6, 7, and 8. 5, 6, 7, 8. So out of port 2, let's add 15,000 ohms of resistance. So I believe that this is 15,000 right here. Let's test it. Oh yeah, so continuing out the breadboard, I'm sorry. So we're going to use these to power the op amp. We're going to power this with the negative side and power this with the positive side. As you saw in the diagram, it's going to have negative 15 volts coming in from input 4 and positive 15 volts coming in from input 8. So these are all connected going across in a line. So for example, if I were to plug one in here, and then plug a second one in here. Is it not? Why is it not? So going across a row, there's a metal strip underneath it. So if you were to power 1 here, all of that would be the same. Also, each of these can be considered a ground too if you plug it into something separate. So, for example, if I were to go here and here, these are 2 different spots. So this is actually, this starts at one place, ends at another, so we can consider one the beginning and one the ground. However, if I were to throw another one in a place, like let's say here and here, actually this could work. This is considered to be in series. Let me show you up here. This is considered to be in series because it starts at one end, jumps across to here, and goes to here, which is along the same spot, the same hole. You can see right here, and then jumps across to here. So if I were to put like a voltage in here, it would jump here, then jump here. However, it would also jump across the end over here too. And this right here goes across that entire strip, which means that port number 7 of the op amp would also be having a current going through it or a voltage across it, because, or if I put a voltage here or a current here, because it's within the same spot. However, if I go further out, it's once again ground because it's not connected to any spot. So you can put them in parallel too, which would be like this. So I'm starting it right underneath spot 4, and so then right underneath spot 4 and going down to some random arbitrary location, and that would give me it wouldn't be connected to the op amp at all. And if I were to go and plug it into the same beginning and the same endpoint, if I remember correctly, I believe this is in parallel. And I mean, I guess we can test it, so that we can test them individually. So I would get my multimeter out. I would measure across from one end, black being ground, to the other end, and my multimeter says 5.05 kilo ohms. 5.05 because I believe this is multimeters has only a certain percentage accuracy, and I believe that this one itself is 5,100 ohms. And so then this one right here, the end, I guess you can't see it, the end and the beginning. If I were to measure these, the multimeter says 10.02 kilo ohms. So you add them together, it should come out to 15,000. So if we put them in series, which is by putting one in connected to the same spot as the other, and then going across to some arbitrary spot. Show it here by going to this one, because again they're all the same. So you can kind of see it. The negative terminal will touch the beginning or the end, whichever you consider beginning or end. Going across to the other side, touch the other resistor, and it comes out to be 15.08 kilo ohms. So now if we put them on the same slots next to each other, so this one will go in here, and then this other one will go in to the same slot as the other one. If I remember correctly, I think this is parallel. So if we measure it now from here to here, it should come across something different. And the multimeter says that this right here is 3.35 kilo ohms. 3.35 kilo ohms. That is 3,350. Get calculator out. So we know that to calculate resistance, okay, well, that's not working. Hopefully you can read upside down. You can't see that. Oh. It's going to be 1 divided by that resistance. So we have 10,000. So 1 divided by 10,000 plus 1 divided by, because it's 1 over z equivalent, 5,000. Then we get the value of that, which happens to be 0.0003. Then now to find the z equivalent, we have to take 1 over the z equivalent. I can show you 0.0003, and it'll give us our z equivalent, or in this case just our resistance, and it comes out to be well, so then you see 3,333. So if we just measure this one more time to verify that this is indeed it, the value that comes out is, it's a little off, but it's 3.35 kilo ohms, which is 3,335, or 3,350. But I think one of them is 5,100, so it would still be accurate. Okay, so this is parallel, and then if you were to move one over, so let's say if I move it back to this slot right here, where it's 1 off, that turns back into series, because once again, 1 is connected to the beginning, 1's not connected, it's connected to some other spot. So if I were to measure it now across it, the multimeter gives me, oh, I should probably go here, huh? 15.09 kilo ohms, which once again is series. Okay, which would be for 15.1 or 15,100. So that's series, that's parallel, that's the difference. That's how you set them up. So we want 15,000 kilo or 15 kilo ohms or 15,000 ohms going across out of port 2. So we will move this one to right here. Shoot, hold up quick. I'm bending the thing more than it needs to be bent. Alright, let's try this again. So now we have this one going into slot 2. Can't really see it, can you? Here's one up here, and then it's going into slot 2. So one is here, and then 2 is here. So it's coming out of slot 2, and it's going to some random arbitrary slot that's outside the op amp, which is being powering this whole spot right here that it's on, whereas this one's being powered across the whole op amp. So now we need to go plug this in here, which would be the same as powering this. So this continues the jump over and plug this into another spot. It doesn't matter where. So now we have this jump to here going across, and this jump to here, which is now considered ground because we don't have anything else. So then we measure across that, that'll be 15,000 ohms, or 15,100. So now that satisfies the first part. The first part wanted us to put 15,000 ohms of resistance coming out of port 2. As you can see, it's right here. But it also wants us to go to the other side, which then comes to be out of port 1. So we need to connect port 2 to port 1, and this is called the negative feedback right here. So we will get one of our wires, Doesn't matter what wire, just a wire. That these ones, I mean, you can get other wires too, but basically you see the metal, it's male to male. So coming out of port 2, it ends over here. So we're going to plug something in here along the same part as the end, so it's connected to ground. So now we're connecting this part to ground too, technically. Now we're going to move it back up and connect it to spot 1. Alright, so now 2 is connected back to 1, so it comes out of 2, goes across here, then it moves over because it's along the same line. Let's do this, just put it on the side, kind of see. So then it jumps across here, moves over, jumps across here, moves over to all these, then jumps across this wire back to port 1. So this is the negative feedback going from 2 to 1. And in this direction too. 2 gets fed back into, 1 gets fed back into 2. Because 2 is our, according to the sheet, 2 is our inverting input. And if you look at the diagram, 2 is the inverting spot, the non-inverting, the positive spot. Okay, so now that we got that done, the next part is to get the capacitor in line with spot 2 in series. So what that means is that it's got to be at least touching one spot and then go into some random arbitrary value. So what I would do is, I've got a capacitor here. I believe this is the right one, 104. For the purpose of, we'll just say all these capacitors are right. So separate it. I'll come to port 2 where the resistance is coming out, or I should say going in. I would stick one into port 2 and then at some arbitrary value somewhere else, not port 1 because I don't want to connect to the op amp. So if we stick it here, it goes into port 2, then it's port 1, we skip it, so you can see there's a spot in the middle, and we go right outside the op amp. So then I want my V input to go in there, so I'm actually going to do this. So the cool thing about wires is just to move it over one slot. That's all I did, just move it over one. So you kind of see that this is 2. Then skip, so this is 2, skip 1, and then go right out to the op amp. But I'm actually going to connect this to here and connect this to here, to 30. So what I actually did here was I jumped it, so anything that's going out here is going to be jumped to this side, and this is going to be the same as whatever was on this side that I've jumped from. So because it's ground, it's kind of technically ground too. Well, it's not really, yeah, it's technically ground. It's the top part of ground. So I'm actually going to stick another wire there because this wire now is going across here is going to measure the value of V in. So I'd actually just clip it right here. Next thing we do is have the non-inverting inputs, or 3, come out, follow that, go down, and it hits this spot right here, which is common to everything on the bottom, and then it goes straight to ground. So which means that the non-inverting input is actually going to be connected to ground, and so is everything across the bottom, where this is just a solid line, so everything else is connected to ground at that point. So out of 3, 1, 2, 3. So 3, I'm going to plug into 3, and then you can connect it anywhere. I'm going to connect to 35. So now 35 lit up all the way across to here. Not here because this is on a separate thing. But from here to here is now going to be ground. Now, that's something that's connected to the bottom of the ground. Except for V1. So we will have the bottom part of V1 measured across somewhere across 35. And then this part right here will be clipped so it can hold the value of the oscilloscope or something for V1. Now we just need 2 more wires, and I'm going to cut the video because it's already getting really long. Alright, so then 2 more wires. Sorry, we're going to use 4 more wires. So this is the input for V1, the top part of V1, because it came out of this, which is connected to the end of the capacitor. We also need 1 to connect to ground. So I guess we can say that this and this, because this is ground because it's connected to 3, these 2 will be the inputs for VI. Sorry. So these 2 will be the inputs for VI. Where this one is going to be the top, and this one's going to be the ground. Then we're going to need 1 going across V1. Well, V1 is going to be also connected to ground, so we'll connect with the ground for it. And then it's coming across the top out of 1. So it's coming right out of 1. We're going to go to 1, just right here, and we're going to connect it. So it's right underneath this one right here, because this white one's connected to right outside. So right underneath it, we will actually put it right here so you can probably see it better. Stick that in. Sometimes these wires put it in there. So that's going to be the input for it, connected to 1. And this will be the top of V1. So now we have V1 and this one, which will be top of V1 and the bottom of V1. So this will be connected to ground, this will be connected to the output of 1. So now we can measure across V1 and we can measure across VI. So the last thing we need to do is set up the negative voltage right here going into port 4 and the positive voltage right here going into port 8. So what I would do is I would actually use this right here, or can't see that, use this right here to my advantage. So use this for the negative, as it shows a negative. On yours you'll see it, but they show on the blue at the top negative, and at the bottom it shows a negative, and the positive is on the red side. So I'll actually get 2 short wires. So okay, so I got 2 short wires, a black and a red. Let's use red for positive and black for negative. Alright, you know what? Let's just stick to it. So we'll use red for the positive 15 and we'll use blue for the negative 15. So the negative 15 is going to come out of, okay, so we're going to power the op amp negative 15 volts, and that's going to go into the slot 4. So slot 4 is the bottom of this op amp right here on the left hand side. So right here, okay, so then this will be slot 4. This will be powering the negative portion. And in slot 8, which is on the other side right here, the very top right hand side, that's going to be the positive 15 volts. It's going to go to the op amp. I'm going to plug in right there at the top the positive 15 volts. And so now this one is going to power the 15 volts from the some type of generator. It's the box on the left hand side in the lab. But we do need one more for that box. So it doesn't display on the actual thing here, but that one we'll use black for. This will be ground, because on that machine that you're going to power it with, you're also going to need one to plug one into ground. So we'll actually just stick that one over here, which is connected to number 3, which is ground. So we'll just stick it in here, and now we have a ground for the machine. Now for these ones, I'm going to use this to power the negative one, the black to power the negative, and then the green to power the positive. So I'm going to actually come down here into the negative. I'm going to stick a negative in here, and then I'm going to stick the, actually just move it down one, stick the negative in here and stick the positive in here. Then this negative one, I'm going to grab the negative. I'm actually going to stick this into port 4, and port 4 is right here, so there's an empty slot right here. So this is port 4, the bottom left, and that's going to power this cable, the blue one, which is going to hold our negative 15 volts. And this one over here is going to be the positive. I'm going to stick into port 8 over here, and then this is going to power this red one, which is also 8, which is going to be for the positive 15 volts. And then once again we have this black one over here as ground for the input for the machine in lab. So that's what the circuit looks like. Oh yeah, going back to here. So now I need 2 more wires, and then I'll be done. I'll use the red one for live, or sorry, the orange one for live. Plug it to the positive side, and then the black one for the negative. And it'll come into the negative side. Plug that into here. Kind of see it now. So now these 2 wires, I'm actually going to plug in the power to these 2 right here. So this one's going to hold the power of the positive voltage and the power of the negative voltage, and then it's going to go across to this whole row. This one's different because this whole row is going to be the voltage, or the amount of voltage we're passing through, and this whole row is going to be the amount of voltage passing through. So it's going to be negative 15 volts, all it's going to be negative 15, positive, all it's going to be positive 15. That's going to like messing with these too much unless they're power sourcing. And then that's it. That's the circuit right there. And it matches up to the diagram right here. So we have the 2 VI not. So this is the top part of the ground, the bottom of the ground it's talking about. This it's coming out of port 2. This one's going to ground. This is V1. This is coming out of port 1, and this is the bottom part, which is still ground. And the negative 15 volts and the positive 15 volts. And we set up the wires to power those going through 8 and 4. We had a 15,000 kilo ohm resistor. Sorry, 15 kilo ohm resistor, 15,000 ohms, and it's coming out of port slot 2, but it's also getting pushed right back into. Sorry, it's going the other way. It's coming out of the 1, and it's getting pushed in, going across, and then coming back into 2 as an input and output, going across, back, input, output, going across, back, input. The purpose of this is, like I said, this is negative feedback. So if these have to be close to each other, these have to be right around each other. So since this is connected to ground, this is 0, so this has to be 0. And if this is giving like a higher voltage or something, Then going in, it's an op amp, so it's an operational amplifier. So if it's a small change, it's not really close to the change of 0, then this is going to get amplified by a huge amount. And so the negative feedback does is it goes across the resistor, brings it back to the correct level, and brings it back down so it goes back to 0, so they kind of level off. And then it goes across, so you have the VI. And there you go. That is the circuit for it.